Hi everybody. In this video we're looking at the practice set solutions for isosceles and equilateral triangles. So we're looking for the unknown variables. So in number 1 we are given an equilateral triangle, so all the sides are congruent. So I know that x is 10 and y plus 3 equals 10, so that y equals 7. So again, this is an equilateral triangle. In number 2, we're given an isosceles triangle because the two sides are congruent. So I can set these two expressions equal to each other and solve for x, and I get 14. So how can we check that? We can put 14 back, substitute 14 in for x, and see 2 times 14 minus 9 is 19, and the other one, 14 plus 5 is 19. So that's a check. In 3, we also have an isosceles triangle, so that means the base angles are congruent. So I can say 6x minus 1 equals 77. I can add 1 to both sides and divide by 6, and I get 13. Now I can plug 13 in for x to check my answer, and I get 77. Okay, so 4 is similar to 2. It's an isosceles triangle, so I can set the expressions equal. I'm going to subtract 8x to both sides and then subtract 3. Simplify. I get 11x equals 11, so x equals 1. So let's check it here. 19 times 1 plus 3 and 8 times 1 plus 14. I get 22 for both. That's our check. Okay, so 5, we know that the base angles are congruent. Therefore, the sides, or the legs, must also be congruent. So I can set up these expressions equal to each other. 5y minus 2 equals 13. Add 2 to both sides. 5y equals 15. Divide both sides by 5, and I get 3. So let's put 3 in for y, and I get 15 minus 2, I get 13. So there's our check. Okay, for 6, I also have the base angles are congruent. So I can say 8y minus 16 equals 72. And I could solve for y, and I get 11. Now I also need to find x. So I can say 9x plus 72 equals 180. Because we know the sum of the angles of a triangle is 180, and we get x equals 4. And then there's my check. 7, in the diagram below, L1 is parallel to L2. Find all of the lettered angles. And I know this light green triangle in here is isosceles. So let's find A first. I know it's a linear pair with angle 134. So A would be 46. And then I know this angle here is 46 of alternate interior. I've got some corresponding angles here. C is going to be 46. D is going to be a linear pair with 46, so I can find D is 134. I know F is also going to be half of 134 since it's showing the bisector, which is 67. E is going to be supplementary with D. And there it is. I found all my triangles. 16 is Triangle ABC Isosceles. Explain your reasoning. Well, we already know that angle ABD is congruent to angle CBD. So I probably should have written that. We know that segment BD is congruent to segment BD. That's the reflexive property. And I know that angle ADB, let's see, I know that angle BDC is 90 degrees because it's a linear pair with angle BOA. So now I have triangle ABD is congruent to triangle CBD because it's angle side angle. So we've proven the two triangles are congruent, so we know that AB is congruent to CB by the corresponding parts of congruent triangles are congruent. So now we can say that triangle ABC is isosceles because the legs are congruent, A, B, and C, B. Okay, that was a mouthful. Let's move on to 17. Okay, 17, triangle EQL is an equilateral triangle. We can see the markings on the drawing. If segment EU bisects angle LEQ, find. Alright, so let's label as much as we know here. Because this is equilateral, all the angles are going to be 60. And then the bisector here, EU, is going to cut the 60 in half, so we get 30 and 30 there. And then now we can kind of label, we can fill in the unknowns here. And we also know that EQ is 4, so therefore when that bisector comes down onto that side, it's going to cut it in half, so I get 2 and 2. Okay, let's see. Determine if the following statements are always, sometimes, or never true. 18. Base angles of an isosceles triangle are congruent. Always. All right. 19. Base angles of an isosceles triangle are complementary. Well, that would be sometimes. If we had a 45, 45, 90 triangle, then the base angles would be 45 and 45, and that adds up to 90. 20. Base angles of an isosceles triangle can be equal to the vertex. That would be sometimes. If we had an equilateral triangle, all the angles would be congruent. 21. Base angles of an isosceles triangle can be right angles. Never. There wouldn't be a triangle. If the base angles are 90, the sides will just end up being parallel and they'll never intersect. And there's no vertex with that. 22. Base angles of an isosceles triangle are acute. That's always. They got to be less than 90. Or like before, they don't intersect. Okay, 24. Fill in the blanks of the proof below. So we're given an isosceles triangle CIS with base angles C and S. Segment IO is the angle bisector of angle CIS. So let's write down the given here. We're given the isosceles triangle, and segment IO is the angle bisector. So what can we use the base angles theorem here? Well, I can say that angle C is congruent to angle S. Then I can say that angle CIO is congruent to angle SIO because the definition of an angle bisector. And then the reflexive property always says that something is congruent to itself. So segment IO is congruent to segment IO. Now I can prove some triangles are congruent. I can say triangle CIO is congruent to triangle SIO because of angle side. And then I can say that segment CO is congruent to segment OS because of corresponding parts of congruent triangles are congruent. And then I can again say angle IOC is congruent to angle IOS because of CPCT, congruent parts of congruent triangles are congruent. And now we can say angle IOC and angle IOS are supplementary. That's the definition of a linear pair. And then we can say the measure of angle IOC equals the measure of angle IOS. They're both going to be 90. That's the congruent supplements theorem. And then there's the proof statement here. Segment IO is the perpendicular bisector of segment CS. We have all the things that we need. We've got, it's a bisector. We know that those angles are 90 degrees. And we know CO is congruent to OS. So it all works. This is the definition of a perpendicular bisector. All right, that's it. Those are the solutions to the practice set. Hope that worked for you guys. See you next time.